All right, today we're going to talk about amplitude change. So what happens when we have a number out in front, right? We used to call that vertical stretch. So we'll see actually how vertical stretch and vertical shrink still applies with sine and cosine. So we're going to stretch the graph and actually make it a lot taller and technically shorter, reach greater heights and peaks in terms of maximums and minimums. Now, my basic sine function, let's just practice that. Remember, sine starts at the midline, and so over here at 0, 0, and if each of these tick marks is 1, we have pi over 2, pi, 3 pi over 2, and 2 pi. So given this, sine starts at the midline, it goes up to the maximum, back down the midline, down to our minimum, and back up to midline. And so quickly, if I have my sine function, my parent function is going to look something like that. Now the reason I wanted to do that first is to see, okay, how does my parent function change with this amplitude change? So y equals 3 sine of some angle measure. And so, however, the first point doesn't change. All that's going to change is where my maximum is. And so maybe it'd be beneficial for you to get used to having a dotted line at your maximum, having a dotted line at your midline, which we'll need eventually, and then having a dotted line at your minimum. Now, how do I know what my minimum and maximum are? I know this because this number tells me. This number 3 is your distance, your amplitude from your midline to your maximum, or your distance from midline to your minimum. Remember, distance is always positive. So distance up, distance down, always positive. So our distance is 3. So here's 1, 2, 3. So -1, -2, and -3. Sine still starts at the midline. So we still have a point here at 0, 0. However, because our maximum is now 3 rather than 1, this is being vertically stretched by a factor of 3, so to speak. And so at pi over 2 now, our point should be up here at positive 3. And then sine goes back down to our midline, and then all the way down to our minimum, and then back up to our midline. Now what if I continued this pattern going the other way? So midline, minimum, midline, maximum, midline, what would be next in the pattern would be minimum, midline, maximum, midline. And so if I wanted to connect this function all the way, notice how the graph itself looks very similar. I missed. The graph itself looks very similar, but we have this vertical stretch by a factor of 3. So this 3 is our what's called an amplitude. So we've never used that language before, but think of kind of a heart rate monitor or blood pressure monitor. You want consistency. You want a consistent amplitude or pattern or period so that any inconsistencies would be obvious so you could see what changed and try to fix something before something bad happens. Let's continue with cosine. So this first one was a sine function example. So given here's my sine graph, it is stretched vertically by that factor of 3, so our amplitude changed. What about if our function is 2? If our amplitude is 2, so we have y equals 2 times the cosine of x. Now, if we kind of draw our tick marks, and here is 1 and 2, and here is -1 and -2. Let's see what we get here. I suggested having a dotted line for your maximum, having a dotted line for your midline, which is the x-axis in this case. But soon our x-axis is also going to shift, so our midline will shift. And our minimum, having a dotted line at our minimum. Now we still have the same points, so we still have, this is pi over 2, 1 pi, 3 pi over 2, and 2 pi. Let's do a dotted line with just our original cosine function. So cosine, remember, starts at our maximum. So on our normal unit circle, the parent function of just 1 cosine x, we'd start at our maximum. We'd come back down to midline, minimum, midline, maximum. And so as a kind of dotted line, our graph would look like this, kind of this U shape, almost looks like a skate park to me, but like the bowl that everybody would skate in. Now, what about 2 times cosine of some angle measure? So now my vertical stretch, or my amplitude, is saying the maximum is going to be a positive 2, a distance of 2 up from my midline, and the minimum at negative 2, a distance down 2 from my midline. So instead of starting at 1, we're going to start at the new maximum, which is 2. Still going back to the midline, down to the minimum of negative 2, back up to the midline, and finally our maximum at positive 2. Now if we follow this pattern, so max, midline, min, every tick mark, midline, max, back down to our midline, down to our minimum, midline, max. And so if we were to draw this and try to make it as curvy as possible, but obviously you've seen I've missed as well. Still the same function in terms of general shape, but we can see that this has been stretched vertically, and it's stretched by that factor of 2. So our amplitude is higher. Our graph itself is very similar. It's just reaching a higher maximum and a higher minimum.